This is the 7th and final lesson in the Blender for Beginners course series. Congratulations to everyone who has made it to this stage. Right now, we'll create a fire material. Let's select the fire and duplicate the standard material. Let's name it Fire and move on to setting it up. Delete the principled BSDF node. And I think we won't need the color attribute node either. Select both nodes and press X. For convenience, let's enter local view and create our first node. Press Shift+A and add an Emission node, which handles the glow. Let's connect it to the output, and as for the color, let's specify a color ramp. Press Shift+A and add the node we need. Here, we'll specify the colors of the fire, but first, let's create a gradient node. Press Shift+A and add a gradient texture. Connect it to the factor input of the color ramp node and press Ctrl+T to create the texture coordinate and mapping nodes. As the texture coordinates, let's choose Object and rotate our gradient by 90 degrees along the Y-axis. Shift it along the X-axis. For the gradient type, let's specify a smooth ease. And now, let's work with the color. The flame tongue will be bright red and the base will be a yellowish white. So let's change the colors. We'll replace black with red. I'll make it something like this so that the value and saturation values are at their maximum. But we can notice that this color we see here doesn't match what we have in the viewport. In the viewport, it looks kind of grayer and less saturated. Let's fix this. Go to Render Properties, scroll down, expand the Color Management tab, and here find the View Transform option. It's responsible for displaying color correctly in the viewport. Currently, we have AGX selected. Let's change it to Standard. Now we can see that the colors match exactly. Let's replace the white color with light yellow. To add more colors, click on this plus icon and create 2 more colors. Let's boost them. Increase the value to its maximum and saturation to its maximum as well. Shift the position. We'll do the same with this one. It might be worth shifting the whole gradient a bit higher, so let's change the X value in the mapping node. Great. Fire has transparency. So let's create a transparent BSDF node and mix it with our gradient using an Add Shader node. Connect the transparency node and emission, then connect all of this to the volume or surface slot of the material output. And our fire has disappeared. That's all because we have a pure white color inside our transparent BSDF. And the higher the brightness value, the higher the transparency. Let's lower the brightness and leave it somewhere around 0.2. For this stylized fire, I'd like to create a sort of rim glow. Let's add a Fresnel node. Press Shift+A and see how it works. Press Ctrl+Shift+ left click. We get a sort of highlight on the edges of the object. Let's adjust it using a color ramp node. Increase the contrast. We can also change the IOR value, and we get a lively, active mask like this. To use it, let's duplicate the color ramp and emission nodes. Press Shift+D, connect the gradient texture, and delete some colors we don't need. And let's mix the 2 gradients using a Mix Shader node. We'll use our mask as the factor. Connect the first gradient as the first shader and the second gradient as the second shader. Let's see what we've got. We get a highlight like this. We can change this yellow to a lighter shade by reducing the saturation. We can also change the mask itself to make it larger or smaller. And we get a fire material like this. Let's transfer this material to the other objects. Select them while holding Shift. Select the object with the material last. Press Ctrl+L and choose Link Materials. Also, let's transfer the fire material to the windows. Enter Edit mode and select the required faces. Then go to the Material Properties and create a new slot. find the fire material here and click the Assign button. Also, let's place a light inside this window. To do this, let's create a new plane. Press Shift+A, Mesh Plane. In Edit mode, place it inside the window and assign the material we need to it. Let's mirror this plane to the opposite side using a mirror modifier. The fire material doesn't fit the windows very well, so let's duplicate it. In this duplicated material, we'll delete the second gradient. Let's also remove the transparency. It won't be needed here. We'll leave just the first gradient with the emission. Let's do the same for the bottom window. Select it and assign a new material to it. But since the gradient texture is applied to the object based on its position in the mapping node, our entire gradient is currently colored in a single red color. Let's duplicate this material and tweak the X position so that the gradient looks correct. Perfect. Let's create a water material. To do this, let's select the object, duplicate the standard material, and name it Water. Inside it, delete the principled BSDF node and create two new ones instead. The first is Transparent BSDF, Transparency, and the second is Glass BSDF, which will generate reflections. Let's connect our color attribute into the Glass BSDF and type in the refractive index of water, IOR, as 1.33. Let's mix these two nodes using a Mix Shader node. As the factor, let's connect a Layer Weight node. Let's see what this node does. Click Ctrl+ Shift+ left click. We see a sort of highlight on the edges of the object, which we'll use as a mixing mask in the blend parameter. Let's change the value to 0.6 and plug it into the mixing factor. Let's see what we've got. Right now, we see a material like this. This is because we are in Material Preview mode. It will actually look a bit different once we enable rendering. Let's create a new node called Principled Volume. We have a lot of parameters available here, but we only need the color and density settings. Connect the volume output into the volume slot of the Material Output node. By changing the color, we'll change the color of the volume. We don't see anything right now, but I suggest making it a bit bluish. Density will handle the thickness. Let's decrease the density and leave it somewhere around 0.7. Right now, our water material is almost ready, but we can make it a little more interesting. Add some caustics, which is the light refraction on water. Now, we'll need a Voronoi node again. Create a Voronoi texture and connect the texture coordinate and mapping nodes to it. Specify object in the coordinates and duplicate this texture. Change the type to Smooth F1 and change the size, scale, to 0.6. Let's also adjust the size for the first texture and connect the mapping node. Let's blend them using a Math node. Connect distance into the values and change the operation type to subtract. Let's see what it looks like. Let's fine-tune this with a color ramp node. Increase the contrast and we get an effect like this. If you want, you can change the size of this texture, its position, and its rotation. Let's paint this texture. Let's change the white color to something bluish or turquoise. Now we need to connect this to the main shader. To do this, let's create an Emission node, Glowing, and connect it to the color ramp. Create an Add Shader node and mix our shaders together. Right now, the glow looks very strong, so let's lower it to 0.5. It's almost gone now, but it will be noticeable on the final render, though you can increase it if you like. So we've finished setting up the materials. Let's take a look at our location. To maximize the window to full screen, I press Ctrl+Space while hovering over it. Let's see how our materials look. Up until now, we've been working in Material Preview. Let's switch to the Render Display mode, Rendered, and we'll see that our scene looks like this. That's because there are no light sources in it yet, and we have a basic rendering engine selected. Let's go to the Render Settings, Render Properties, and change the render engine from Eevee to Cycles. Cycles is a more advanced, realistic render engine. Before switching over, I highly recommend saving your project. Select Cycles. We see an image like this. Now let's change the device from processor, CPU, to graphics card, GPU compute. If you have a dedicated graphics card but for some reason it doesn't show up here, let's go to Edit, Preferences, System, and under your Hardware Architecture section, make sure it's checked Active. If you don't have a graphics card, don't worry, just stick with the processor. I'll select the GPU. I have a standard GTX 1660, which is perfectly sufficient. Let's lower the maximum sample count, max samples, in the viewport to 256. For the final render, let's lower it to 512. That will be plenty. Also, let's limit the render time to 30 seconds, time limit. Let's keep denoising enabled for the render, but we don't need it in the viewport because, as you can see, the materials immediately look sort of blurred, so it's better to leave it with that pixelated grid look. Let's move on to creating the lighting. To do this, let's create a separate collection and name it Light. First, we'll need an HDRI map. Simply put, this is a 360-degree image that will cast light on our model from all sides, creating the base ambient illumination. We'll set up the HDRI map using an add-on called Easy HDRI. It's free. You can download it via the link in the description of this video. This opens up Gumroad. Here we have a feature description and a short video tutorial. To download it, just set the price to $0, since it's free, and click I want this. It takes us to the checkout page, but since it's free, just enter $0, put in your email, and hit the Get button. After that, the download starts. To install the add-on, go to Blender, Edit, Preferences. Open the Add-ons tab, and here, click Install from Disk. Find the archive, install it, and then search for Easy HDRI in the search bar. Activate this add-on, and after that, it will appear in the right sidebar menu, the In panel. Let's close the preferences and head over to this add-on. Since we don't have any HDRI maps loaded yet, it says empty here. You can download HDRI maps from the Polyhaven website. It has a super handy category sorting layout, and we'll download a regular daytime HDRI map, one with a sky and ground, like this one, for example. Here we can choose the quality. A standard 2K resolution will be enough, and the file format should be EXR. Then click Download. The exact HDRI map I'm using in this lesson will be linked separately in the description for you to download. Returning to Blender, to open the HDRI map, click on this icon. Find the folder where you downloaded your HDRI. I recommend creating a dedicated folder for 3D assets, and inside it, a separate folder for HDRIs. That's where all your HDRI maps will live. Give Blender access to this folder, and now thumbnails of all the HDRI maps inside it will appear. Here is my list. Let's select this HDRI map and then click Create World Nodes. Our HDRI map is loaded. Now, to hide the background, let's click this icon here, making it transparent. Let's also lower the strength of the sky glow. I'll leave it at 0.1. And let's rotate the HDRI map by 115 degrees, giving us an evening, twilight sky lighting setup. Let's create a camera. Turn off rendering for a moment. We won't need it right now. Press Shift+A and select Camera from the menu. It appears at the world origin. Let's move it 25 meters along the x-axis, minus 25 meters along the y-axis, and 25 meters along the z-axis as well. To switch to the camera view, click on this icon here. Let's change the angle along the x-axis to 60 degrees. Leave y at 0 and set the z-axis to 46 degrees. Since we need a square aspect ratio for the render, let's go to the output properties. Copy the value 1920 from resolution X and paste it into resolution Y. Now we have a square aspect ratio. Let's also go to the camera settings, data properties, and set the focal length to 80 millimeters. The larger the focal length, the closer the object feels to us. The smaller it is, the wider the field of view. Let's adjust the camera position, tweaking it along the X and Y axes. Let's try to center our location perfectly in the composition. Let's create our first light source. It's going to be a sun. Press Shift plus A, go to Light, and add a sun. The sun appears at the origin. Let's move it up 10 meters on the Z-axis, 7 meters along the X-axis, and shift it slightly on the Y-axis. Under the rotation parameters, type 42 degrees for Y and 30 degrees for the Z-axis. Let's head over to the light settings. Here we can specify the color and intensity, strength. The angle parameter controls the shadow softness and diffusion strength. Let's enable interactive viewport rendering and give it a bluish, cool tint. Let's also increase the strength and set the angle to 20 degrees. However, the emission from glowing objects, like the campfire, torches, and windows, only casts a small amount of light, which unfortunately isn't enough. So, let's add a new light source. Press Shift plus A and under Light, add a point light. This is an omnidirectional light source. It distributes glow in all directions. Let's position it right here near the campfire and increase its intensity. Let's set the wattage to 200 watts, power, and change the color to a bright yellow, maybe even somewhat orange. Move the light source slightly higher and increase the radius. The larger the radius, the softer the shadows cast by the light source. Let's duplicate this light source. Press Shift plus D and move it to the torch. Switch to solid view mode and place it somewhere around here. Bring it down a bit, turn on the render view, and switch to the camera view. Let's reduce the power. Right now, it's way too intense. Let's set it to 80 watts. Duplicate this light source again. Press Shift plus D and move it along the Y-axis to the next torch. Copy the point light source once more, place it near the window. Lower the radius, and position a similar light source inside the window on the right side of the castle. For artistic impact, we can accentuate the roof outline using a rim light. Let's add a new light source. Press Shift plus A light and add an area light. Move it up 9 meters on the Z-axis and shift it 5 meters on the Y-axis. Rotate it -90 degrees on the X-axis so it faces the castle and scale it up. Let's stretch it along the Z-axis. It might be a good idea to push it back a bit further. Let's do 7 meters along the Y-axis. Now, rotate it slightly on the Z-axis and shift it -15 meters on the X-axis. This positions it right behind our fortress. Increase the wattage, power, to 360 watts. Give the light a bluish hue. Now duplicate it. Press Shift plus D and move it to the other side of the castle. Rotate and adjust it so that it creates a subtle rim highlight. I also suggest duplicating one of the point lights and placing it inside the balcony. To emphasize the castle's volume and separate the front facade from the side, let's create one more light source. Press Shift plus A and add an area light. Move it 9 meters up the Z-axis and 9 meters down the X-axis. Scale it up. In the shape parameter, change its type to ellipse. Rotate this light source 50 degrees on the Y-axis and 30 degrees on the Z-axis. Let's set its wattage, power, to 150 watts. You can see that the front side has become brighter. Let's change the color from pure white to a slightly warm, yellowish, or even orange tint. If this lighting seems too bright to you, we can drop the power value down to 100 watts. Honestly, this amount of lighting is already enough to hit render. But feel free to add more light sources, accentuate specific elements like highlighting the pier, or add more rim lights. And now that the location is ready, we can render it. To do this, go to the Render tab in the top menu and choose Render Image, or simply use the hotkey F12. I'll press F12 and a new window pops up. This is where the image rendering takes place. Here we can track the progress, how much time has passed, how much memory is being used, and the number of samples rendered so far. Don't forget that we have a 30-second limit set, but if your hardware isn't very powerful, you can set a higher value to get a cleaner result. We've got our image on a transparent background. Let's close it and edit it. To do that, switch to the Compositing tab and check the Use Nodes box to activate the node system we'll use to overlay effects onto the final render. Let's adjust the workspace. Instead of the outliner window, let's open the image editor. Make it a bit bigger and select Render Result as the image. To see the final composition, let's add a background image behind our render. To do this, create a texture node, click the plus sign, and create a new texture. Click on this icon to jump into the texture settings. In the type dropdown, choose Blend, scroll down, and switch the gradient type from linear to quadratic sphere. This gives us a nice circular gradient. Let's color it using a color ramp node. Plug the color output into the factor input, and let's blend the generated background with our render. To do this, add a mix color node. Connect the alpha channel of our render into the factor socket. Connect the background to the first image slot, A, and the final render into the second slot, B. Output the node to the composite block and the viewer node, and you'll see the background mapping perfectly behind our render. We can scale this texture up. Let's make it fill the entire frame. We can also stretch it out, along the Y-axis, for example. Let's apply colors to it using the color ramp node. We'll use our reference image as a benchmark, picking colors directly from it using the eyedropper. Let's turn Render Result back on and finish adjusting the gradient. Change its interpolation type to a smooth ease. Feel free to slide the markers around or add new ones, like creating an extra, brighter one right in the center. We can also shift this texture. For example, I want to move it along the Y-axis by -0.15 so it sits right behind the top part of the tower. There are also post-processing nodes available. For instance, let's add a glare node. Connect it right after the mix color node and switch its type to fog glow. Let's zoom into the final image to see the effect better. Find the threshold parameter and adjust its value. Lowering it reduces the threshold for bright areas that get highlighted by the glare node, meaning the lower the value, the more areas will glow. Aside from that, we can change the size of this glow using the size parameter. Let's drop it down to 0.3. We can also alter the glow's intensity using the fade or mix slider. If we set it to 0, the glow disappears entirely. Let's increase it to 0.8. We get these beautiful, pleasant glows on the torches, windows, campfire, and other bright objects. You can also do your final color correction right inside Blender using nodes. To do this, let's create a hue saturation value node. Alternatively, you can use RGB curves or brightness/contrast. If you've worked in image editors before, I'm sure you're familiar with RGB curves, hue, saturation, contrast, and so on. We'll plug these nodes in right before blending with the background gradient. Here, we can tweak the hue and saturation to make our location vibrant and colorful, or modify contrast with the curves, making the bright spots brighter and the dark spots darker. And in the end, we get a beautiful render like this. To save this image to your computer, head to the Image menu and choose Save As, or simply use the hotkeys Alt+S. Give it whatever name you like and specify the file format type. I'll go with a standard PNG. Under the color parameter, select RGB since we don't have any transparency left in this final composite. For color depth, choose 8-bit. We can turn compression all the way down to 0. After that, click Save as Image. Congratulations, you have just created your first ever render in Blender 3D. But since we also have the option to animate this scene, let me show you how to do that. Let's switch back to the Layout workspace. This is where we'll set up our animations. Let's pull up from the bottom to create another window and choose the timeline. By moving the playhead slider, we select the frame we need. Let's stop at frame 0. For better visibility, let's change the model shading from flat to matte cap. As you remember, we used empties to control the texture offset on the torches, water, and flag. To create an animation, we need to set keyframes. Let's press I. This brings up the menu with animation parameters. Let's choose location, and we can see that a keyframe appeared at frame 0. It captured the exact position of our object at this moment. Now, let's jump over to frame 80 and move our empty along the Z-axis. After that, press I again and set a keyframe here. Now, an animation is generated between these two keyframes. Press spacebar to play it back. However, this keyframing method isn't the most optimal choice when animating looping elements like water, fire, or a waving flag. So, let's select our keyframes and delete them. Instead, we'll use expressions that automatically control the movement speed of these objects. Let's go to the Z-axis property field, and instead of a numerical value, let's type in this formula. Add a hash symbol and type frame. Add a slash and divide this expression by 25. After doing that, let's hit spacebar to preview the animation. Now we can see the empty shifting along the Z-axis at a consistent speed. It will keep moving like this until the final frame, which is 250 in this case. All that's left is to copy this animation data to the other empties. Let's select them while holding down Shift. Select the animated empty last, press Ctrl+L and choose Link Animation Data. Let's check out the resulting animations. As you can see, all the torches are now fully animated. Let's write the exact same formula for the empty controlling the water offset. Select it, and let's type it into the Y-axis field. Hash frame divided by 35, making the water move slightly slower than the fire. Let's see the results. We'll type this exact same formula for the flag too. To save the animation, let's first trim it down to our desired duration in seconds. There are 24 frames in a single second, so let's multiply 24 by 6 seconds, which gives us exactly 144 frames for our animation timeline. Go to the Output settings and choose the directory where your file should be saved. Scroll down and under the File Format dropdown, select FFmpeg video. We want to save it as an MP4, so under the Encoding tab, change the container from Matroska to MPEG4. After that, go to the Render tab in the top menu bar and select Render Animation, or use the hotkey combo Ctrl+F12. Rendering even a short animation loop using the Cycles engine can take a lot of time, sometimes up to several hours, so be prepared to wait a bit. At the end of our Blender for Beginners course, we have built this beautiful island fortress. Congratulations to everyone on completing the course and making it all the way through. See you next time!